Imagine for a second that you're driving down the highway, you're sipping your morning coffee, you're listening to music, and then blam! The car in front of you suddenly slams on its brakes.
Oh, yeah. The worst feeling.
Right. You instinctively stomp on your own brake pedal, and in that split second, your seatbelt locks across your chest, your coffee sloshes violently onto the dashboard, and, your heart just jumps into your throat.
It feels like pure chaos.
Exactly. It
Yeah.
feels like chaos. But the reality is, every single thing that just happened in that terrifying little moment, from the friction of your tires gripping the asphalt to the exact trajectory of your spilled coffee, it is all perfectly governed by a set of rules published way back in 1687.
It's completely predictable. I mean, what feels like a sudden emergency to you is actually just the universe strictly enforcing its baseline code.
Yeah, everything in that moment is dictated by this invisible framework. So today, welcome to the deep dive. We're taking your research on Sir Isaac Newton and turning those dusty textbook laws into a practical, everyday lens for your life. Because once you see the physics operating behind the scenes, you really can't unsee it.
No, you totally can't. It's everywhere.
So, okay, let's unpack this. Before we dive into the math, let's look at the mind that actually cracked the universe's source code.
Yeah.
We're talking about a time way before computers, right? Before modern labs. How did one guy in the 1600s figure all this out?
Well, to understand Newton, you really have to look at the landscape of science when he was born, which was 1642.
Okay.
Before him, physics was deeply fragmented. You had people like Galileo who had studied how things moved down here on Earth, like balls rolling down ramps, that sort of thing.
Right.
And then you had astronomers like Kepler mapping out how the planets move up in the heavens. But everyone just assumed that Earth physics and heaven physics were two completely different rule books.
Oh, right, because they thought the stuff up in the sky was made of some perfect divine material, right? Like they wouldn't play by the same rules as rocks and dirt.
Exactly. It was seen as separate. So Newton's true superpower wasn't just observation, it was synthesis. He studied at Trinity College at Cambridge, completely immersing himself in math and optics. And in 1664, Cambridge established the Lucasian Chair of Mathematics, which is this incredibly prestigious post, and Newton eventually became only the second person to ever hold it.
Wow.
Yeah, and during his time there, especially during the years he was sent home because of the Great Plague,
Working from home, basically.
right, the original work from home setup, but that's when he really started connecting dots that no one else saw.
Okay, but wait. I mean, people had been dropping things for thousands of years. What made his realization so different? Like, was it really just the famous apple falling on his head?
Well, that is kind of the ultimate scientific myth.
I-
Yeah. The apple is just a helpful story to visualize gravity. His real genius was looking at that apple falling and then looking up at the moon.
Okay.
He was the first person in human history to realize that the exact same invisible force pulling the fruit to the dirt is the exact same force keeping the moon tethered in its orbit.
So he just zoomed all the way out.
Exactly. He realized there aren't two rule books for the universe, there's only one.
Man, he basically brought the heavens down to Earth. And he didn't just stop at gravity, right?
Oh.
I mean, he proved white light is a mixture of colors using a prism.
Oh, yeah.
He invented the reflecting telescope in 1668, swapping out glass lenses for mirrors to fix color distortion. He even co-developed calculus just to have the math to prove his theories.
He literally had to invent a new type of math just to explain his ideas.
That's wild. And the guy was eventually knighted by Queen Anne in 1705 for all this. But his ultimate mic drop is the book he published in 1687, right?
Yeah, the Philosophia Naturalis Principia Mathematica, or, most people just call it the Principia.
Yeah, much easier to say.
Definitely. And in it, he laid out 3 fundamental laws of motion that govern absolutely everything.
So if the Principia is the rule book,
Yeah.
let's look at page 1, the first law. Because I always love thinking about this rule as the universe's inherent stubbornness.
Oh, that is the absolute best word for it. The first law is formally known as the law of inertia.
Okay.
And it essentially states that an object desperately wants to maintain its initial state. So if a body is at rest, it absolutely wants to stay at rest.
Right.
And if it is moving in a uniform straight line, it wants to keep moving in that exact same way forever.
So basically, objects are fundamentally lazy.
Precisely. They will not change their behavior unless an external force acts upon them. And actually, this is profound because it gives us our scientific definition of a force.
Oh, because force is the only thing that can overcome that laziness.
Exactly. Force is what overcomes an object's stubborn inertia.
Okay, let's bring this back to the listener sitting in their car,
Mm.
because this law explains exactly what happens when you hit the gas or the brakes.
Oh, absolutely.
So it breaks down into two types, right? The inertia of rest and the inertia of motion. So let's say you're sitting at a red light, the light turns green, you stomp on the accelerator, and your body throws itself backward into the seat. Why does that happen?
Well, you aren't actually moving backward.
I'm not.
No. Your lower body is in direct contact with the seat of the car, so it's being pulled forward by the engine. But your upper body, your torso and head, they have their own inertia of rest.
Oh, okay.
They stubbornly want to stay exactly at the geographic coordinates of that stoplight. The car is literally driving out from under you until the seat back physically catches your torso and forces it to accelerate too.
I love that. And I guess the inertia of motion is the exact inverse, right? Like you're cruising at 60 miles an hour, your body's moving at 60, you slam on the brakes, the car stops, but your physical body stubbornly wants to keep doing 60.
Right, so you keep flying forward until the seatbelt catches you and applies that external force needed to change your state.
It's wild to think about.
You see this everywhere once you start looking. Think about a track and field athlete preparing for a high jump. They don't just stand under the bar and jump straight up
No, they take a long running start.
because they need to bank that stubbornness.
Yeah.
If they try to jump from a standstill, their body's inertia of rest fights them. It wants to stay on the ground.
That makes total sense.
By sprinting first, they build up this massive